Hello, I'm Bill Carless and I'm the Sales Manager at Broadberry Data Systems. I'm joined today by two of our key partners, ASUS and Intel, and we'll be looking at how we can provide solutions to solve the problems we see in today's new reality. We now live in a world that faces more uncertainty than any other time in our recent history. The global economy, new regulations, COVID-19, and how competitors are adjusting to meet this new reality are just some of the challenges facing commerce and manufacturing and all business today. Many companies only look to short-term fixes, but long-term planning is essential to cope with and thrive in today's times of uncertainty. It is not easy, but for these problems to be solved, we need to balance short-term focus, but take the time to build long-term strategies. Gaining a competitive edge is key to long-term stability. Today we'll be looking at some of these areas and looking at how Broadberry are working with our partners to provide the tools to solve them. This may be how we manage a remote workforce, centralising the creation of creative content, or adjusting our logistics chains and manufacturing processes. Above all, they should be tailored to the business needs, remove blockers and create an environment that is sustainable and allows for growth. We'll start by looking at some of the projects we have worked with and the solutions we have provided to meet these needs. I want to share with you some insights in a few projects that Broadberry have been working on recently, together with our partners ASUS and Intel, who are Broadberry. Predominantly selling custom-made PCs and servers to the computer trade, Broadberry Data Systems was founded in 1989. Since then, we have significantly expanded our portfolio of rack mount product and now specialise in the sale, supply and support of highly customisable industrial server and storage solutions. As a result, the company has grown in every aspect and become one of the success stories within the industry. Today, the Broadberry Group has offices in the UK, USA, Europe and the Far East, and due to our constant innovation in emerging technologies and an uncompromising approach to the reliability, we now list Google, Amazon, NASA and CERN amongst our customers, and almost all the major universities. At the heart of our extensive product range are two flagship ranges, the Broadberry CyberServe range of servers and the Cyber Storage range of storage appliances. Both are built to meet the demands of a broad spectrum of use cases and are multi-award winning, having won best class accolades for their respective markets over a number of years. We have a close relationship with our key partners, enabling us to put together tailored solutions to meet the needs of our customers. We work just as closely with you to make sure we understand the issues you are seeing and how we can most effectively and efficiently solve them. I'd like to introduce you to Dilip Ladani, who's our GPU and AI specialist.
Thank you, Bill. Hello, I'm Dilip and I am one of the senior account managers at Broadberry UK, specializing in AI, rendering and digital content creation. A few months ago, we were approached by a multinational semiconductor manufacturer who were looking to implement a multi-GPU AI platform utilizing CUDA to analyze their customers' buying trends, product placement, and marketing. Their then incumbent supplier provided a competitive solution which caused issues on their platform when running all 8 GPUs simultaneously and was also 1U too high. We were aware that ASUS had a very similar Intel scalable system to the one being supplied, but the ESC 8000 had one advantage of being only 4U high instead of 5U, which helped in rack density, which was a plus factor. But the major benefit was that the ASUS ESC 8000 could support all 8 GPUs within the client software stack. Another benefit of this server is that it doesn't require dual CPUs to run all 8 GPUs. This made more commercial sense for this project, as the application was more intensive on the GPU than the CPU. Apart from the 8 PCIe slots, the ESC 8000 comes with 3 extra slots for add-in cards like RAID and networking, and also supports 8 hot swap SATA or NVMe drives. There is also dual M.2 slots, which we used for the operating system. The 4U footprint, running 8 GPUs simultaneously, and the saving on a single CPU put the ESC 8000 in pole position. They prefer the ease of setup from the BIOS to the installation, so much so that they removed all the incumbent servers and now have an all ASUS-based GPU estate. The combination of Broadberry, ASUS, and Intel provided the perfect solution and delivered the most cost-effective platform to meet the client's tight budget constraints. So thank you, ASUS and Intel, for your continued support.
I'd like to introduce you to Will Shaw, who's one of our account managers.
Thank you, Bill. Hi, my name is Will, and I'm an account manager at Broadberry Data Systems UK. A few months ago, one of our long-term customers, a well-known construction engineering company, created an online quote using our web configuration tool. They were looking to update a strategic part of the traffic control system for Highways England. As well as a redundant power supply, Intel Xeon CPU and 64 gigabits of RAM, the key criteria were the height and depth of the system, which needed to fit within the space available, as well as offering a minimum of 12 network ports. As this was a specialist requirement, we arranged a conference call with the customer, as well as the team at ASUS, to establish the strongest possible solution. Broadberry have worked with ASUS directly for over 10 years and have provided thousands of successful servers and storage solutions to some of the world's largest brands. We have found that our close relationship with Intel and ASUS has enabled us to continue to supply customers on time and on budget, even in today's climate of shortages and constraints that have affected so many other system integrators in the market. Broadberry clients expect the latest technology and demand market-leading reliability. Throughout our partnership, we have always found ASUS to meet these expectations and as such feel confident providing ASUS-based solutions to our customers. The solution that best fit this project's criteria was the ASUS RS300, which could offer all of the technical specifications and could be delivered within the client's budget. The system comes with redundant power supplies, dual PCIe expansion capabilities, as well as features you would expect from ASUS, including complete server management via the ASUS Control Center, high power efficiency, and the latest server innovations. This allowed us to meet all of the requirements, supporting 4 2 or 3.5-inch SATA drives, 2 internal SSDs, and 2 M.2 NVMe's in any combination. The storage was flexible, giving ample room for future expansion. In total, after the 4 onboard network ports, and by adding 2 Intel quad-port network cards, we provided a total of 12 ports in a low-cost, single CPU system. With the support of ASUS and Intel, we were able to deliver the project on time and within budget. Thank you, Bill. Back to you.
I'd like to introduce you to Morton, who's a country product manager from ASUS.
Hi everyone, my name is Morton and I'm the country product manager for servers at ASUS. And I would really like to talk to you today about the way that we uniquely approach every problem that we see customers have and how we utilize the power that Intel is providing us. So ASUS isn't just servers, of course. We produce a large variety of different products, and we always try to keep the same approach to every single one of these, which is to keep the customer in mind and make sure that they are not only produced to the highest quality, but also to our own highest standards. And we never release anything without having properly tested. For this, we have managed to be the most admired company for 6 years, from 2016 and 2018 to 21, which in itself is quite an achievement. But one of our biggest priorities is to keep a green ASUS. We have managed to acquire over 72,000 individual green labels as part of our corporate social responsibility. And I want to show how we translate that into our products. So in 2017, we introduced the performance tuning team. And since then, we have managed to gain over 900 world records in the spec. We mainly do this not only to produce the most powerful, but also to try and make the most power efficient servers out there. And with this, we have managed to grow this team, and in the last year alone, we have acquired over 300 world records. So, firstly, I want to talk about the power balancer, which is available for Intel dual socket systems. This is a technology we utilize with Intel to get the most out of the CPUs, while still keeping them really efficient. It uses a dynamic monitoring system, and it feeds back CPU loads to help accurately manage the systems. And this we have seen that this lowers the power consumptions when the CPUs are running between 40 and 90% load, which, let's face it, is what they do most of the time. So in this power balancer, we have the auto frequency adjuster that can change the frequency depending on the load that we are looking at. And then we have the enhanced power efficiency that basically helps getting more out of the system with less power. Secondly, we have Thermal Radar 2.0, which we utilize to help lower the overall power consumptions of all our servers. So what we basically have done is that there's already sensors sitting in CPUs, SSDs, and all the add-on cards. But we have added another 56 sensors to this. And we've also divided the servers up into individual zones. And then what we basically do is we have fans allocated to each of these zones. And if one of these zones is running particularly hot, but the other ones aren't, then it would only be the affected zone that increases the power. Now, sometimes all power is needed, which is why we have made this thermal radar be able to communicate with other ASUS servers sitting in the same array. And there's not really a big limit on how many. So what we can actually do is, if you have one particular server that's running on a heavy load because it's rendering your newest video, then what it will do is that it can increase the fan speeds of the servers surrounding it to reduce the overall ambient temperature. And this will save you power in the end, because as we all know, as IT gets hotter, it gets much more inefficient. So we want to keep it as cool as possible, while still reducing cost. Overall, we have seen that this lowers the TCO significantly, and we've seen an overall reduction in fan power by 36%. So lastly, we have the core optimizer. Now, this is something we have introduced because with every investment in IT, let's face it, it's not small. CPUs are easily hitting several grand, and well, the same can be said to GPUs and other components. So we want to make sure that everyone gets the most out of their hardware when they buy ASUS. So with the core optimizer, what we've done is that you can lock in the frequency that the processor is running at, even on multi-core operations. Now this avoids all the shifting and instability as the processor is suddenly not changing, and this reduces jitter and allows us to lower the frequency. Pair that with the optimized performance setting. This is the running joke that ASUS takes a good time to validate every single component going into our server, and this is true. But this is the reason, because within every single BIOS, we have made sure that every component will run perfectly. You have pre-configured BIOS settings that you can use to, depending on the workloads that you're putting into the servers, and this improves performance and efficiency.
I'd like to introduce you to Simon and Alex from Intel.
Hi everyone, my name's Simon Windsor, a Field Sales Engineer at Intel, and this is Alexander White, a Field Application Engineer also at Intel. It's our pleasure to be here with you today with Broadberry and ASUS, and we'd like to talk to you about how wonderful gets done with Intel 3rd Gen Xeon Scalable Processor family, and also touching on our One API programming language. It's clear, not just through the pandemic, but previously, that business needs and demands are dynamically shifting. At Intel, we're focused on 5 key segments within the data center: cloud, HPC, AI, 5G, and the edge. If we look at these together, we can see that across the EU, the Western EU, GDP, as measured by IHS Markit, is forecast to grow at a compound annual growth rate of 2.8% over the next 5 years. If we layer on top of that server CPU demand and a total available market, Intel forecasts believe that that will grow at 7.1% over the next 5 years with a compound annual growth rate. Looking at cloud specifically, we're forecasting that market to grow 10.1% over the same time period. At Intel, with the pandemic and with COVID over the last few years, we can see that demand for compute and cloud technologies has grown exponentially as people look to work from home, look to play or game from home, and also as children look to learn from home. But on top of that, we've experienced that the manufacturing sector has outgrown services over the COVID period as demands from financial institutions, demands from manufacturing, and demands from healthcare and services has grown, causing new workloads in HPC and AI. If we look at 5G technologies and the emergence of 5G, a report by Ericsson Mobility in November 2020 forecast that an annual compound growth rate of 33% of data moving across the networks. When we look at all the devices being added to the edge, we can see an exponential growth in the number of devices coming online and connected to the internet. All of this creates what we call our virtuous cycle of demand, where as new users come on board, more compute's needed, and then new workloads are established as more and more users and devices come online. So we continue to see this growth as we look forwards. For Intel, when we look at the future of the data center, we're kind of working behind 3 key concepts: security, XPUs, and then software. So looking at security, one of the key technologies we're working on is something called SGX, software guard extensions. As more data is being stored in the cloud and as more data is being generated, SGX is looking at how that data can be shared securely. So data tends to have 3 states. It's either idle, it's either in use, or in transit. And how do we protect that data in each of those states? Software guard extensions enables us to put part of that data in secure memory enclaves directly on the architecture or the chip level in a secure enclave, and then you can choose who and where to share that data with. CPUs have been great for the last X number of years, but we've also seen the emergence of GPUs, FPGAs, and other accelerators, which at Intel we're grouping together as XPUs. It's clear that as these architectures come on board, each require today different programming languages and interfaces, and we'll be talking a little bit about our One API initiative, which will target how we program in some of those languages. Finally, for the future of the data center, software becomes increasingly important. Not just software, but also the emergence of microservices and microservers on different APIs and different workloads, which are really enabling scalability across the cloud and across on-prem applications. At Intel, our hardware is underpinned by the strategies above, and one of our strategies is looking at how we process everything faster, how we're able to store more data, and how we're able to move that data faster across the networks. You'll be familiar with some of the brands highlighted in this picture, but also some of the emergence of our new brands, such as our Intel Z graphics and our Trofino switches for some of the hyperscaler platforms that we're using out there. But all of this is underpinned not just by the hardware, which we optimize and validate to work seamlessly together, but by the software and experiences and workloads that people come to expect when trying to get the most out of the products we provide. So with the software and the services, we're going to go into a little bit more detail on One API shortly. But with that, I'm going to hand over to Alex, who's going to talk about some of the key workloads and benefits that we see from our 3rd Gen Xeon Scalable platform.
Brilliant.
Alex.
Thank you, Simon. So really, when we look at the cloud and enterprise segment, we're really seeing over the last year, industries and businesses have had to move to a very cloud-first and digital-first approach. So with this, we've seen the emergence of microservices and also how we can scale workloads from on-prem to hybrid cloud and beyond as well. One of the real important things we've seen is as the need for virtualization, which enables enterprises to take multiple workloads and run them on the same physical hosts, we've seen this be very important to generate more scale and more ability to move workloads and to scale workloads across a global industry as well. But then, of course, as we're seeing that emergence of microservices as well, that also comes into play to be very important to be able to scale a workload from on-prem and onto the cloud as well with seamless integration. So really with HPC, we're seeing this as the need to be able to solve some of the most complex challenges we face at the moment and really using compute and compute density to achieve those. One of the things we've definitely seen over the last few years, and we're seeing this continue going forward as well, is that the convergence between AI and HPC is becoming more and more obvious as well. So with this, we've built some hardware technologies into our platforms, and one of the ones specifically on HPC is with our AVX512 instruction sets. And what this enables you to do is with highly parallelized applications, it enables you to get more performance, which you wouldn't natively be able to get from the standard platform as well. Now with our third generation scalable platform, one of the key things we've done here is we've added more cores, increased level 1 and level 2 cache sizes, and with this it means that the execution units within the CPU are kept busy as well, so applications can run at a faster speed and improve the performance as well. Now for IO-bound workloads, we've introduced the PCIe Gen 4 onto the platform, and really with PCIe Gen 4, this enables storage devices, networking devices to work at a massively increased bandwidth as well. And then on memory-bound applications, we've introduced our persistent memory Optane 200 series, which we'll talk about in a little bit as well. So with AI, we've seen AI growing massively, and AI at the edge and AI in the data center as well. And one of the key things we've done with AI is we've taken a very software-first approach to this. And this means that we've looked at how data scientists work with models, we've worked with data sets, and we've made sure that we've brought optimizations to some of those key software stacks they use on a daily basis. One of the key things here is we've got an Intel optimized version of TensorFlow and also Intel optimized version of Python, which are really key tools for many data scientists and people working in AI at this moment in time. Now, taking the software optimizations is really key, but then we've also looked at how we can improve the hardware side. And we've also introduced our VNNI instructions on the platform as well, which enable an even greater level of performance using that instruction set as well, making sure that the hardware is optimized and the software is optimized in parallel as well. So just taking a little bit more of a look at some of the key technologies we've introduced and how they can really help solve some of those key technical challenges you might have. So looking at Optane persistent memory, it enables us to utilize up to 6 terabytes of memory per socket, which is an absolutely huge amount, and means that many memory bandwidth bound applications can really get a huge performance benefit from that technology as well. One of the other key parts of this is as you introduce any new technology, it's important to make sure the software is optimized and also the software ecosystem which customers are using and running their applications on is also optimized for this as well. So what we've done here is we've worked with many ISVs, many software partners to make sure that there's Optane optimizations within the software, but then also it's validated for as many software products as well. So for example, we've got Azure HCI, we've got VMware optimizations, as well as and a huge amount of in-memory database applications which can fully take advantage of this as well. So just moving on to the network side, and we kind of just spoke about how our third generation scalable family has an increased amount of I/O bandwidth. And this really enables you to introduce faster networking and really scale your performance between nodes into a cluster and then across the globe as well. So with our 800 series network adapters, we're able to achieve speeds of up to 100 gigabits per second per port, and this really enables you to scale workloads as well. One of the key things we've looked at here is looking at what protocols customers and developers are using to make sure that we are really aligned with how people are building their applications. And as we see storage starting to scale between nodes, technologies like NVMe over TCP and RDMA becoming more and more important, and we've got full support for those protocols on our hardware as well. And back to you, Simon.
Thank you, Alex. So hopefully we've given you a little bit of a flavour of some of the key technologies that we have on the hardware side. But as we mentioned before, software is becoming increasingly important. So with that, we'd like to introduce our Intel One API program initiative. You can see on the slide here, there are many forms of architectures from CPUs to GPUs to FPGAs and other accelerators. And the CPU is well known as a kind of general compute workhorse. But as we go through the graph and up to accelerators, you can see that a CPU is maybe less performant than an FPGA in performance efficiency. So what we're planning to do with One API is really look at the software stack and the programming languages behind each of these architectures and come up with one unified programming language that you can then use on a CPU, a GPU, FPGA, and other accelerators. So with that, I'll hand it over to Alex, who will take you through in a little bit more detail.
Brilliant. Thank you very much, Simon. So really, as Simon explained, as we look at that key programming challenge, many workloads want to scale and utilize accelerators to really get that improved density, improved performance, and of course, looking at that overall TCO for a workload as you scale it. Now, at the moment, if you start utilizing many accelerators, many different hardware platforms on an application, the actual size of your application and the complexity of it hugely increases. And that's really because you've got tools very specific for each hardware platform. And then also you're utilizing different libraries. You've got internal different skill sets aligned to each of those hardware platforms. But one of the really important things is not many applications align to just one type of hardware very well. Often you will have some scalar-based workloads, some vector-based workloads, or maybe some matrix workloads in many of those AI-based applications as well. And that's really where One API comes in to help solve that programming challenge. So really, this is where One API comes in. And One API is an industry initiative based on standards and an open specification to make sure that no matter what hardware platform you're utilizing, you've got a unified programming model underneath, which means that if you're working on the hardware level or you're interfacing with the hardware at a very low level with your application, you're able to utilize that and reduce the complexity of your application. But then, of course, you're absolutely going to be able to get benefits of that as well if you're working on many abstraction layers above that, since you're able to utilize those cross-platform benefits which One API brings as well. Now, really with One API, the really important thing here is because we're making it open, we're making sure it's industry standardized as well. It's how can we get it to the developers and make the developer journey as easy as possible. So with this, we've got our One API-based toolkit, which has all of the libraries and programming models included to get you off the ground and start looking at your application in more depth. But then we've also got different toolkits aligned with those different key domains, which are very dynamic and very specific in terms of some of the software tooling. So for example, we've got toolkits based on AI, HPC, and then also we've got our OpenVINO software stack as well, which enables a really powerful level of optimization for those AI workloads as well. So one of the key things I said there is we're trying to make it as easy as possible for developers and make sure that developer journey is as streamlined as possible. So with this, you can go and download One API today. You can get started. You can look at your application and see where it could fit best. But then also we've got our Intel Dev Cloud. And with our Intel Dev Cloud, this means that you're able to test your application in the cloud, see where the benefits of One API can work with your application, and then make sure you can develop that and move that onto your production environment based on hardware as well. And with that, back to you, Simon.
Thank you, Alex. So hopefully we've given you a flavour of what's happening at Intel with our 3rd Gen Xeon Scalable processors and the platform behind that, but also on the software front. Unfortunately, today we only had a little bit of time to really scratch the surface on some of those key technologies. But if you would like to understand more information on anything that you've heard today, please feel free to reach out to your Broadberry account manager. We work extensively with Broadberry and ASUS on access to early samples, on key insights into new technologies. We have developer and engineer level relationships, early samples, early roadmap updates, etc. So they're well aware of all the technologies that we've got coming down the line. And it's great that Broadberry have been able to take advantage of the work that we've been doing with ASUS as well to enable all of the technologies you've heard today on their platforms. So if you'd like to learn more, please reach out to your Broadberry account manager. If you need even more information after that, we're more than happy, myself and Alex, to set up a 3-way NDA, and we can have a real deep dive on any of the subject areas you've learned today. Alternatively, please feel free to check out the URL below, and you can go on and find out more information on all of our Intel data center products. So with that, thank you, and thank you once again to ASUS and Broadberry for letting us present today. Thank you.